In this video, I would like to show you some examples of applying the chain rule to find the derivative of exponential and logarithmic functions. And I've stated the chain rule kind of in my own language up here without a lot of crazy words and weird symbols. And I've stated it to be that we should take the derivative of the outer function, leaving the inner function alone, and then we'll multiply by the derivative of the inner function. So as I walk you through these examples, I will use and refer to this definition and kind of a very similar wording. Before we go into some examples, I've listed here some fun facts when it comes to finding the derivatives of exponential and logarithmic functions. These are 4 good formulas to have as a kind of a reference. You might even consider putting them all on like a cheat sheet so that as you're working through these types of problems, you have it to refer to. And it will help you, I think, as you're working problems to refer to kind of a condensed sheet of these formulas as you're trying to commit them to memory. All right, let's jump into our first example. The first thing that I would like to do is to find the derivative of this function, negative 3e to the power 3x squared plus 5. And to start, we will identify the inner and outer functions, and also notice that our function is an exponential with a base of e, which means we will apply that first fun fact that we just showed. And so let's go ahead and identify the inner and the outer function. So in most cases when you're dealing with an exponential, the inner function will be represented by that exponent. So 3x squared plus 5 is our inner function. And the outer function is the negative 3 base e to some power. And as you can see, the derivative of our outer function, since it has a base of e, will just be itself. So to find the derivative of this function f of x, we will take the derivative of the outer function, leaving the inner function alone. In this case, the derivative of the outer function is just itself. So we will write that as negative 3e, and then again we leave that inner function alone, so I'm going to write it as 3x squared plus 5. And now to account for the inner function, we multiply this guy by the derivative of the inner function. By the power rule, the derivative of the inner function is simply 6x. And so to state the final answer of the derivative of this using the chain rule, I'll just do a little bit of mop up to say that the derivative of f of x is equal to, we'll multiply the negative 3 and the 6 together for negative 18. I'll move the x to be in front of the exponential expression, and then I'll write my base e to the power of 3x squared plus 5. And that is the derivative of f of x. So once again, we identify the outer function as being the exponential with a base of e, and the inner function is represented by that exponent. And so in keeping with that, we'll move on to a second example that looks very similar, but the base of this exponential is not e, it's 4. And so we will apply the second fun fact here to find the derivative of the outer function. But before we do that, let's identify the inner and the outer function. So once again, the inner function is the exponent, so negative 5x plus 2, and the outer function is the base of 4 to some power. So to take the derivative of this using the chain rule, we will take the derivative of the outer function based on this rule, leaving the inner function alone. So let's go ahead and do that. The derivative of a base of a to a power of x is equal to the natural log of the base. So in this case, that will be the natural log of 4 times the base to its power. So in this case, the base is 4, and the power is our inner function, which we are going to leave alone at this point. So there's the derivative of our outer function, leaving the inner function alone. And now we'll multiply by the derivative of the inner function. By the power rule, that is -5. So again, to state the final answer, I'll just do a little bit of mop-up or rearranging here. The -5 is like a coefficient, so I'm going to bring that up front. And so the final answer for my derivative of f of x is -5 times the natural log of 4, and I'm just rewriting everything else. And the exponent -5x plus 2. So again, just to hit this idea home, when you're dealing with an exponential function, your outer function is typically your base raised to some power, where that power represents the inner function. Let's move on to an example involving logarithms. Example number 3 asks us to take the derivative of the natural log of -8x to the third power plus 2x. Our logarithm in this case is a natural log, and so we will use that third fun fact, which says the natural log of x has a derivative of 1 over x. And we will very quickly here identify our inner and outer function. Our inner function is most often what is inside the grouping symbols. So in this case, it's -8x to the third power plus 2x. And your outer function is the natural log of something. And so to take the derivative of f of x using the chain rule, we will take the derivative of the outer function, leaving the inner function alone, based on our rule here. So the derivative of the natural log of something is simply equal to 1 over that something. And for now, we leave that something, that inner function, alone. And then to account for the inner function, by the chain rule, we multiply by the derivative of that inner function. And applying the power rule, we know that the derivative of -8x to the third power plus 2x is -24x squared plus 2. So we move the power down in front and then decrease the power by 1 and do the same thing for the second term. So here we have the derivative of the outer function leaving the inner function alone, and then we've multiplied by the derivative of the inner function. So to state our final answer, I'll just clean this up a bit. We know that to multiply with fractions, we can look at this as being over 1 and then multiply the numerators together and the denominators together. So this ends up being -24 x squared plus 2 all over -x to the third power plus 2x. This is just a fine final answer for this problem. You might notice that we can actually factor out from the numerator and denominator and cancel. But when it comes to finding derivatives using the chain rule, this is a perfectly fine final answer in this case. So -24x squared plus 2 all over -x to the third power plus 2x for your derivative of f of x. All right, and for a fourth example, we will take the derivative of another logarithmic function, but in this case, we don't have a natural log. We have a regular logarithm, the log of 4x minus 3, and we again will identify the inner and outer function, and then use our fourth fun fact when we take the derivative of that outer function. Before we do this though, recall that when you don't see a base, we will assume that it has a base of 10. That's going to be important when we apply this formula. So our inner function is, again, what's in the grouping symbols, so 4x minus 3. And our outer function is the log base 10 of something, where that something is our inner function. So by the chain rule, we'll take the derivative of f of x by taking the derivative of the outer function, leaving the inner function alone, and we'll do that using this rule. So to find the derivative of log base a of x, we do 1 over the natural log of the base, which in this case is 10, times what the logarithmic is of. And in this case, that represents the inner function, which we are leaving alone for now. So here we have the derivative of the outer function based on this rule, leaving the inner function alone. And now to account for the inner function, we multiply by the derivative of the inner function, which by the power rule is simply 4. And so for our final answer, we will combine this to be 4 over the natural log of 10 times 4x minus 3.